Okay, welcome back. This is Mr. Hassan's Maths channel, and here we have question number 7 from the October 2023 International A-Level Pure Mathematics P4 exam from Pearson's Edexcel. Here we have a question which is basically about differential equations, and we're told about the number of goats on an island is being monitored. While monitoring began, there were 3,000 goats on the island. In a simple model, the number of goats, x in thousands. Now that's really important here, and that throws off a lot of people. X is the number, x is in thousands. Okay, so, for example, if x turns out to be 5, that means 5,000. So it's very important for you to realize that, especially in answering some of these questions. So that's something for you to take into account straight away. A lot of people don't read the questions carefully, and they miss out on those things, and they'll lose marks. So in a simple model, the number of goats, x in thousands, is modeled by the equation x equals k times, in brackets, 9t plus 5 over 4t plus 3, where k is a constant and t is a number of years after a monitoring. So t is in years. Show that k equals 1.8. So we have some information here. We know that when the monitoring began, which is when t equals 0, there were 3,000 goats. So x equals not 3,000 but 3, because x is measured in thousands. So when I say x equals 3, that means 3,000. And again, that's going to be important, and there's the reason why I think they told you to show that k equals 1.8 is because if you use x as 3,000, your answer will come out incorrect. So I think that's the reason why they have done that, to make it apparent that, hold on, think again. Okay, so that's, sometimes they do that to push you back on the right track in case you had a misunderstanding. So that's kind of a bit kind of them. But anyway, so show that k equals 1.8. So we know x is equal to 3, and we know that time is equal to 0. Okay, and we got to find k. So we're going to have 3 equals k times, you're going to have 9 times 0 plus 5 over 4 times 0 plus 3. So we end up with basically 3, let's put it down here, 3 equals, that's going to be 5k over, and that's going to be 3. Why did I put the other extra line? I don't need the extra line. 5k over 3. So therefore we can say k is going to be 9 over 5. 9 over 5, and 9 over 5 is 1.8. So we can see that k equals 1.8 as we should have shown. Alright, so there's the answer to part A. Then it says, hence calculate the long-term population of goats predicted by this model. So what we can say here is x is equal to 1.8 times 9t plus 5 over 4t plus 3. So that's going to give us the following: 1.8 times 9. That gives us 81 over 5, which is 16.2. So you have 16.2t plus 5 times 1.8. That's going to give us 9 over 4t plus 3. So basically the long-term population means when t becomes something really large. We can say when t reaches infinity. Now there's a few ways of doing this. It's only worth 1 mark. So you don't really have to show any steps. What we could do is we could do this. We could take a very large number, like for example, let's say 10 million. That's one. Just say it's a bit bigger, 10 million. 1, 2, 3, that's 10. Yeah, 10 million. I'm going to press equals. So that's now the answer in my calculator. Then I'm going to do 16.2. Okay, times answer plus 9 over 4 times answer plus 3. Okay, so I'm just putting the big number in that place of where t is, and that's going to give us 4.0499. So you can see it's basically getting closer and closer to 4.05. So we can say as t approaches infinity, x approaches 4.05. Okay, which would then be 4,050. Okay, so therefore we can say the population, okay, is going to be 4,050, because you have to multiply by 1,000, because remember it's in thousands. All right, that's one way of doing it, and that would be perfectly acceptable if you did that in the exam, and just putting t as a large number and writing that down. Okay, but there's other ways of dealing with it. Like, for example, we know that this is a reciprocal graph. If we were to draw it, and you'd have two asymptotes. You'd have an asymptote when t is negative 3/4, which of course doesn't make sense, and you'll have another asymptote. And we learnt about the asymptote if you divide these, these two numbers, the leading coefficients here. If you divide them, you get 16.2 divided by 4, and that gives you 4.05. Okay, so that means there's going to be a horizontal asymptote at, in this case, it's going to be x equals 4.05. Okay, so that's going to be basically the long term, that's the asymptote that's going to be reaching. All right, that's another way of thinking about it, just dividing the leading coefficients if you have something like this. A third way of dealing with this question, which I'm going to show you, is if we rewrite it so that it's easy for us to kind of algebraically deal with it. So if you divide both the numerator and the denominator by t, you'll get 16.2 plus 9 over t divided by 4 plus 3 divided by t. So we know that as t approaches infinity, as t gets really large, okay, then this is going to approach. So as t gets really large, then this 16.2 plus 9 over t over 4 plus 3 over t is going to approach 16.2 over 4, because as t gets bigger, 9 over t it goes towards 0, and 3 over t goes towards 0. If you make t really big, you have 9 divided by a really huge number. It's going to get smaller and smaller and smaller as this number gets bigger. So as t approaches an infinite number, the 9 over that infinite number is 0, approaches 0. So you end up getting 16.2 over 4, which is 4.05, which means the population is going to be 4,050. So whichever way you do it is fine. Okay, whether you think about it from the asymptote, whether you think about it from just putting a value, a very large number in here, or you think about it from this algebraic method, all of them are perfectly fine ways of proving or showing that the long-term population of the goats is going to be 4,050. Now for the next question, it says in the second model, the number of goats x in thousands is modeled by the differential equation 3 times dx dt equals x times 9 minus 2x. So the first part of the question is asking us to rewrite this in partial fraction form. So that's got nothing really to do with the question right now, but we'll see how it will link to the question in a minute. So you got 3 over x times 9 minus 2x. And we want to rewrite this and split it into separate fractions. So we have two linear factors in the denominator. So we can say that this is going to be a over x plus b over 9 minus 2x. This is not an improper fraction. The numerator has an order less than the denominator. So you're going to end up with something like this, where you have a constant over x plus another constant over 9 minus 2x. And if we multiply through by the denominator, this side will be left with 3, and you'll have a times, if you multiply this by that fraction, the x's will cancel, leaving you with 9 minus 2x, plus b times, if you multiply this term by that, 9 minus 2x will cancel out, leaving you with x. So we can see, for example, when we put x equals 0, the b term will disappear. You're left with 3 equals a times 9, because that's going to become 0. So we can say that a is equal to 3 over 9. So a is equal to 1/3. And we can see also that if we replace, I guess we could replace x with what makes this 0, which is going to be 9 over 2. Okay, we could do that. Let's do that. When we replace x with 9 over 2, when x equals, like we want to make this bracket 0. What value of x makes this bracket 0? It's going to be 9 over 2, as I mentioned, right? So we're trying to make this bracket 0, so the a will go, x equals 9 over 2 will make this bracket 0. So then we have to replace x with 9 over 2 in every part, and that will eliminate the a. So you have 3 equals, that will become 0. You're left with b times 9 over 2. So we're going to multiply both sides by 2. That gives us 6 equals 9b. So therefore b is equal to 6 over 9. So b is equal to 2 over 3. 3 goes into both of those. So we have a equals 1/3 and b equals 2/3. So therefore we can say that 3 over x times 9 minus x will be the same as a 1/3. So it's 1 over 3x plus, and you're going to have b 2 over 3 times 9 minus 2x. 3 times 9 minus 2x. So there we have the answer to this question. Okay, so 3 over x times 9 minus 2x becomes 1/3, or 1 over 3x plus 2 over 3 times 9 minus 2x. And we have now written that in partial fractions. So we might need to use this. So I'm going to copy and take to the next page. Okay, now for part D. It says solve the differential equation, which is this one, which we're given, with the initial condition, which is this, okay, to show that x equals 9 over 2 plus e to the power of negative 3t. So we have to solve this differential equation. Now, this is how I like to deal with solving differential equations. Basically, a differential equation is an equation which has in it a rate like this, dx dt, d theta dt, or some sort of, dx, d something, right? And to solve the differential equation, you have to end up with some function which is going to be like the letter on top of that thing, that dx is going to be x, is going to be some function of what's underneath it, t. So when you solve a differential equation which has y dy dx in it, you're going to write your answer as y equals some function of x. In this case, it's going to be x is going to be some function of t, as we can see here. X equals something with t in it. So that's the objective of solving a differential equation. To solve a differential equation, now people do lots of different things. I like to do things which for me make sense mathematically, instead of things just flying around or whatever. I like to think of, all right, what we're going to do now is we're going to do to one side of this equation what we do to the other. So I'm going to integrate this side with respect to t, and I'm also going to integrate the other side also with, of course, exactly the same thing with respect to t. What I've done to one side, I've done the same thing to the other. And then I'm going to cancel out these on this side, this dt, and I have now something where I've got dx on one side and dt on the other side. So I have to integrate this side with respect to x and this side with respect to t. Now we got some variables on this side which don't belong on this side because they should be where it says dx. So I'm going to divide both sides by x times 9 minus 2x. So I'll have the integral of 3 over x times 9 minus 2x. That has to be integrated with respect to x. And here you're going to be left with just 1, which is going to be integrated with respect to t. Alright. Now what we've got here is exactly what we had in part C of the question, where we had to rewrite this in as partial fractions. So obviously, why do they ask us to rewrite this in partial fractions? Because integrating this and is not so easy, but when you split it like this, it's very easy. So we're going to now rewrite this as the integral of, I'm going to put 1 over 3x plus 2 over 3 times 9 minus 2x, that's integrated with respect to x, equals the integral of 1 with respect to t. Okay, so that's, just to make sure I haven't wrote it down wrong. Okay, good. Now, the other thing I'm going to do is I'm going to use the initial condition, which is this. And this is where I'm going to use it. Now, many people will do this later on in the question. They'll put plus c, then use the values from this. But I like to do things right from this stage here. I think it makes life way easier. But if you like to do it the other way, that's fine, absolutely fine. But I'm going to show you how to do it by putting the limits in at this stage, in which case you don't have to write plus c. The c will automatically be calculated for you. Alright, so when monitoring began means that when time equals 0, x, remember, is in thousands, so x is going to be 3. Okay, so we want to find what x is as a function of time. So x equals, I'm going to put x on the top here in the same level t. I know that when x is equal to 3, that's when time was 0. So I'm putting things in their right levels. So now I can integrate this whole thing and hopefully get to the answer. So when I start integrating, before I start integrating, actually, I'm going to take out a third from this integral. Just to make life, I like to make my integration easier. So I'll take out a third. So I'll have 1 over x plus 2 over 9 minus 2x. I noticed that there's like 1/3, and there's also a third there, which is also a factor of both of those. So I'm going to write that with respect to x equals the integral of 1 with respect to t. Alright, so now we can start integrating, because we're going to have a third times. Now I'm going to get rid of the integral sign, put a square bracket, the ln of x. Now x is a population, it can't be negative, so there's no need for me to put modulus sign, because I know x is a positive value, it's a population of goats, right? So I'm not going to put a modulus sign, but I know the thing is positive. If x was a variable that we don't know whether it's positive or negative, or it's possible that it can be negative, we should put the modulus sign. In this case, there's no need to whatsoever. Plus, to integrate this, I'm using the fact that the numerator is of the form of the differential of the denominator. So I'm going to say that's going to be 2 times the ln of 9 minus 2x, then divided by the differential of what's inside here, which is minus 2. And I have my limits, remember, there were x and 3, so let me write that there. So x and 3, and that's equal to, if you integrate 1 with respect to t, you're going to get t. So you have t and 0 as your limits. Okay, so now this, let me simplify this a little bit first. You have a third, this is the ln of x minus, these cancel out, the ln of 9 minus 2x, and you have your limits x and 3 equals t minus 0. Okay, I'll just put that in straight away. Now what I can do is I can multiply both sides by 3. If I multiply this side by 3 and multiply this side by 3, I'm left with ln x minus the ln of 9 minus 2x, and you have your limits of x and 3 equals 3t. So now let's continue. We can combine these first. You have ln of x over 9 minus 2x, and we have our limits x and 3 equals 3t. So now we have ln of, if you put x in here, it's going to be 9x over 9 minus 2x. Okay, minus, if you put 3 in here, you have ln, that's going to be 3 over 9 minus, that's going to be 2 times 3, which is 6, equals 3t. So that's going to be ln 3 over 3, which is ln 1. So you end up with ln x over 9 minus 2x minus the ln of 1 equals 3t. So we're almost there. This is going to become 0. So what we can do here is we can say that this is like e to the power of 3t is equal to, so it's e to the power of this is equal to that, x over 9 minus 2x. Now we want to rewrite it and have it in this form with x as the subject of the formula. Okay, so I'm going to take a little space here, or I could go to the next page. I could go to the next page, I guess. Take this. Do I have space on the next page? Yes, I do. Okay, so for this now to become like that, I have to make x a subject. So what I'm going to do is I'll multiply both sides by 9 minus 2x. So I have e to the power of 3t times 9 minus 2x equals x. I can now expand this bracket, so I have 9 times e to the power of 3t minus 2 times e to the power of 3t times x is equal to x. I can bring the x's together on one side, so I have 9 e to the power of 3t is equal to x plus 2 e to the power of 3t. Okay, so I've just 1 second, yeah, 2 to the power of e2 times x. So I've basically added this to both sides, so the x's are together now. So I have 9e to the power of 3t equals x times 1 plus 2e to the power of 3t. Okay, and I can now divide both sides by 1 plus 2e to the power of 3t. So I have 9 times e to the power of 3t divided by 1 plus 2e to the power of 3t equals x. Now, how did this become that? Right, this is, it looks almost the same. All right, looks almost the same. I can in fact write it like this. I can swap those two around and it will be almost the same. Now what's happened here is something very it's like 2e to the power of 3t plus 1. Okay, so what we can do here to make it look the same as that is, if I divide the top by e to the power of 3t, then these will cancel out. And if I divide the bottom by e to the power of 3t as well, then this will cancel out and that will become 1 over e to the power of 3t. So by doing that, you'll get what we have to show. So this divided by e to the power of 3t gives us 9 over, if I divide this by e to the power of 3t, I'm left with 2. And if I divide 1 by e to the power of 3t, I'm left with 1 over e to the power of 3t, which is e to the power of negative 3t. And that's exactly what I had to show. So in the end, you have to keep what you have to show in mind and rewrite your answer in that form. Okay, so I guess, yep, that's how we do that question. So that's how we can solve that differential equation that we were asked to solve. It's a bit long-winded, okay, but we got there in the end. This is a little trick at the end that will help you. So there's the answer to part D. Now for part E, it says find the long-term population of goats predicted by the second model. So again, what we could do is we could take our calculator and we could put a very big number instead of t. So for example, let's say something like 1,000,000. We press answer, or press equals. That's now the answer in our calculator. We can set this up as 9 over 2 plus, and you have e to the power of minus 3 times answer, and that should give you 9 over 2. Okay, so we can just say that as t approaches infinity, then x approaches 9 over 2, which is 4.5 for x. So that means 4,500 population. Remember, it's the x is in thousands. Okay, you can say 4,500 if you want, or 4,500. All right, so that's how you can do it by using a calculator, and you'll get the mark for that. But if you want to think about it algebraically, how does that happen? You have something like this: 2 plus 1 over e to the power of 3t. That's how this would look algebraically if you rewrite this. And we know that as we can say, as t approaches infinity, e to the power of 3t also approaches infinity. 1 over e to the power of 3t therefore approaches 0. 1 over something really big approaches 0. So that means this approaches 0. So therefore we can say, as t approaches infinity, then x approaches 9 over 2 plus 0, which is 9 over 2, which is 4.5. So 4,500 population. All right, so that's the algebraic kind of way to do it. That's the way, just putting it in your calculator. It's only worth 1 mark. If you just wrote down 4,500 population, that would be fine. Okay, so that concludes question number 7 from the October 2023 International A-Level exam. There's 1 question left now in this paper. If you would like to see the other questions on the paper, you can click on the link over here. It will take you to the playlist. If you'd like to watch questions dealing with differential equations, you can click on the link over here. You can subscribe to my channel by clicking on this link, and here you can click on the link that takes you to the video, which shows you how to use my channel and how to find what you're looking for. Thank you for watching, and see you soon.